Hello friends, we will see today thermal power plant and coal ash preparation and its handling. This is Professor Afaq Ahmed from Navi Mumbai, India. The development of power in any country depends upon the available resources in that country. Okay, the hydel power totally depends upon the natural sites available and hydrological cycle in that country. The new sites cannot be humanly created for hydel power plant. The development of nuclear power in country requires advanced technological developments and fuel resources. This resource of power generation is not much desirable for the developing countries as it is depend on high technology and they are highly capital based systems. Many times hydel power suffers a drought comes even once during a decade and the complete process of nation stops. Whenever the drought come, the complete process and progress of nation will stop. The calamity of rain drought on power industry has been experienced by many states in this country. To overcome this difficulty, it is absolutely necessary to develop thermal plants in country which are very much suitable for base load plants. It is all about introduction to the thermal power plant. Now this is a schematic diagram or it is a general layout of thermal power plant. The general layout of thermal power plant consists mainly four circuits. First is coal and ash circuit, second air and gas circuit, third feed water and stream flow circuit, and fourth is cooling water circuit. So these four circuits are directly impacting on the layout of modern thermal power plant. A thermal power station using steam as a working fluid works basically on Rankine cycle. Steam is generated in a boiler, expanded in the prime mover and condensed in condenser and fed it to the boiler again with help of pump. However, in practice, there are numerous modifications and improvements in this cycle with the aim of affecting heat economy and the increase in thermal efficiency of the plant. Now first we will see coal and ash circuit, which is located in this diagram on left hand side. In this circuit, to the coal from the storage is fed to the boiler through coal handling equipments for the generation of a steam. Ash produced due to the combustion of coal is removed and transferred to the ash storage through the ash handling system. Now second is air and gas circuit. Air is supplied to the combustion chamber of a boiler either through forced draft or induced draft fan or by using both. The dust from air is removed before supplying it to the combustion chamber. The exhaust gases carrying sufficient quantity of heat and ash are passed through air heater where the exhaust heat of the gases is given to the air and then it is passed through dust collectors where the most of dust is removed before exhausting the gases to the atmosphere through chimney. Third is feed water and steam circuit. The steam generated in the boiler is fed to the steam prime mover to develop the power. The steam coming out of prime mover is condensed in the condenser and then it is fed to the boiler with help of pump. The condensate is heated in the feed heaters using steam tapped from the different points of the turbine. The feed heaters may be mixed type or direct heating type. Some of the steam and power is lost passing through different components of the system. Therefore, feed water is supplied from external source to compensate this loss. The feed water supplied from external source is passed through purifying plant to reduce the dissolved salts to an acceptable level. The purification is necessary to avoid the scaling of a boiler tubes. Fourth one is cooling water circuit, which is located in this figure just below the turbine. The quantity of cooling water required to condensate the steam is considerably large, and it is taken either from lake or river or sea. The cooling water is taken from the upper side of river. It is passed through the condenser and heated water is discharged to the lower side of the river. Such system, the cooling water supply is possible if adequate cooling water is available throughout the year. This system is known as open system. When the adequate water is not available, then water coming out from the condenser is cooled either in cooling pond or cooling tower. The cooling is effected by partly evaporating the water. This evaporative loss, this include evaporation and carryover, is nearly 2 to 5% of the cooling water circulated in the system. To compensate the evaporative loss, the water from the river is continuously supplied. When to cooling water coming out of the condenser is cooled again and supplied to the condenser, then the system is known as closed loop system. Now next is site selection criteria. The selection of site for thermal plant is compared with hydropower plant is more difficult as it involves number of factors to be considered and its economical justification. The following consideration should be examined in detail before selecting the site for the thermal power plant. The location of thermal power station should be made with full consideration and only of trends in the development and location of demand, but also the availability and location of the cheapest source of primary energy. Few important factors must be considered for selection of site for the thermal power plant. First is availability of a coal. The question of using diesel or gas from thermal power plant in India does not arise. These sources are limited. The major source of energy which is available in India for thermal power plant is coal. Therefore, it is necessary to concentrate on the best use of coal for power generation. The huge quantity of coal is required for the large thermal power plant. A thermal power station of 400 megawatt capacity requires 6,000 to 8,000 tons coal per day. Therefore, it is necessary to install the power station near the coal mines. In this case, the power generated must be transported to the long distances. Therefore, it is necessary to find out the location which gives us the lowest cost considering the coal transport and power transmission charges. Energy Survey Committee of India has suggested the use of byproducts of coal for power generation which are commercially unusable product resulting from the process of washing coal where washed coal is essential for metallurgical industry. The committee further pointed out that with increased washing of coal with the development of a steel production, vast amount of middling would accumulate at the coking coal fields resulting the problem of disposal of such waste. The estimate made by the committee for such byproduct of a coal middling is about 4.86 million tons in 1973-74 and about 9 million tons in 1980-81. Next is ash disposal facility. The ash removal problem has become more serious, particularly in India, because the coal used for the power generation contains large percentage of ash, that is 20 to 40%. The quantity of ash to be handled is large, around 1500 to 2000 tons per day. The ash handling problem is more serious than the coal handling issue because it comes out in a hot condition and highly corrosive. Its effect on the atmospheric pollution are more serious as the human health is considered. Therefore, there must be sufficient space to dispose large quantity of ash. A 400 megawatt power station requires nearly 10 hectares area per year if ash is dumped to the height of 6.5 meter. The ash can be easily disposed of to the river, sea, lake economically. In such facilities are available at the plant site. Presently, the ash from the power plant is used for many industrial processes. Therefore, the question of disposal to the sea, river does not arise. Next is space requirement. The space and building requirement by the power station is another point to be considered. The average land required 3 to 5 hectares per megawatt capacity, which includes the space required for the storage of a coal, ash disposal, staff colony, market facilities, and space required for the whole machineries. Generally, the space occupied is 10% of the building, 33% for the coal storage, 27% for the cooling towers, if any, and 7% for the switch yard, and remaining 23% is for other purposes. Next is the cost of land and nature of land. The selected site for power plant should have good bearing capacity as it has to withstand the dead load of a plant and forces transmitted to the foundation due to the machine operations. There are number of cases where the plants have failed due to weak foundations. The minimum bearing capacity of land should be 10 bar. Next is availability of water. Large quantities of water are required for the condenser for disposal of ash and feed water to the boiler and drinking water for the working staff. The quantity of cooling water required in the condenser for the condensing the steam coming out from the turbine of 60 megawatt capacity plant is of the order of 20 to 30,000 tons per hour. If it is discharged to the lower side of the river, if cooling towers are used, then makeup water required also 500 to 600 tons per hour. The water required to feed the boiler, owing to the losses in the system, is also large, that is 6 to 10 tons per hour of 60 megawatt capacity of power plant. This water must be pure as possible to avoid the scaling of boiler tubes. Next is transportation or transport facility. This is another important consideration in the location of thermal power station. It is always necessary to have a railway line available near to the power station for bringing in heavy machineries for installation and bringing the coal. It is always through that. Okay, so it is more important to have a railway line which is vicinity to the power plant. So it is always thought that the site of thermal power plant near the coal pit head is more economical instead of selecting site near the load center. In this respect, it would be the interest to know the statement made by late Dr. Baba in Geneva Conference in 1959 as given below of his own words. It will be seen that at least 75% of the country is devoid of coal, while some 55% of the coal reserves and 80% of the present production are in the states of Bengal and Bihar. This has the consequences that coal is often hauled over a distance of 1500 miles to the areas of the north, west and south. Even when the central India coal fields are fully developed, coal will still have to be hauled over the distance of 700 miles to the areas of south and west such as Bombay, Ahmedabad and Punjab and western UP in north. Thus a million kilowatt of capacity in a coal fired stations at a distance of 700 miles from the nearest coal fired would invoke transport of 3.6 million tons coal over the distance, and this will lock up some 10,000 wagons and 165 locomotives, representing the capital investment is about 175 millions. So that is all about the transport facility. Now UK has decided and have reached to the conclusion that it is more economical to locate the thermal power station at or near pit head rather than load centers. The transport of electricity is more economical for the load above 200 megawatt. Next is the availability of labor. Cheap labor should be available at the proposed site as enough labor is required during construction of the pit. Next is the public problem may also occur. The proposed site should be away from the towns to avoid the nuisance from smoke, fly ash and heat discharge from the power plant. Okay, so these are the general considerations for the site selection, or we can say that is the criteria for site selection of thermal power plant. Now next is coal storage. The purpose of coal storage is twofold. First, fuel storage is an insurance against complete shutdown of power plant occurring from the failure of normal supplies, that is inadequate supply. Okay, so it will give us an insurance. Next, and the second, the storage permits the choice of the date of purchase, allowing the management to take advantage of seasonal market condition. because it is same as that of the seasonal market condition of the vehicles and of the daily usable households and machineries. Because see, if you want to purchase an air conditioner during a winter season, during a rainy season, so the prices of air conditioner will be lessened because of the requirement from the end customer is totally reduced. So we can take such type of advantage during the purchase of coal also. The coal storage is normally sized to have a capacity of a quarter of the annual burn 1.25 million tons for 200 megawatt plant. Okay, if the quantity of staked is height of around 10 meter, it would cover an area of 30 acres. You can imagine, the quantity is staked at the height of 10 meter, it would cover an area of 30 acres. So large amount of area is needed here to store the coal. The storage of coal is undesirable because it costs more, as there is a risk of spontaneous combustion, possibility of loss and deterioration during the storage, interest on the capital cost of the coal lying dormant, cost of insurance, handling cost required by the storage, and reclamation cost of area is required, cost required to protect the stored coal from the deterioration, and many others. With all this disadvantage of the coal storage, it is more important to public service stations, as light and power have become vital and essential in everyday domestic and industrial life. Okay. Next is, scientifically, coal is stored to avoid the oxidation in following. First, stocking of coal in heaps. The ground used for stocking should be dry and level. Generally, floored area is used to prevent the flow of air from the bottom. The coal is piled at height of 10 meter to 12 meter. During storage of coal in heaps, the coal should be compacted in layer of 15 to 30 centimeter in thickness by means of the bulldozers and rubber tired scrapers. This effectively prevents the air circulation in the interior of the pile. The pile top should be given a gentle slope in the direction in which the rain may be drained off, so that water will be removed, but it should not be drained so rapidly as to cause serious washing. Another method of removing the heat of oxidation is, the air is allowed to move through the layers evenly, so that the heat of reaction is carried away and the temperature of coal is maintained below the combustion temperature, that is 70 degree centigrade. The sealing of stored pile is best method of avoiding oxidation of a coal after packing as airtight layer of a coal. Asphalt fine, coal dust, bituminous coating and other coating material are also used for this purpose. Okay, that is all about the stocking of coal in heaps. This is the first method of stocking. So next is, we need to check the temperature at different points should be made. So we need to give the provision to do it. Next is, conical piling should be avoided, and firefighting equipment should be easily available at the storage site. Now next is coal preparation. The preparation of coal before feeding to the combustion chamber is necessary if unsized coal is brought to the site. The coal preparation plant either can be located near the coal receiving point or at the point of actual use. The coal preparation plant include following equipments. First is the crushers, second is the sizers, third is the dryers, and fourth is the magnetic separators. The coal crushers are absolutely necessary to prepare the coal of required size before feeding it to the combustion chamber. The part of coal obtained from the mines does not require sizing and bypassed. The capacity of coal crushing plant must be sufficient to meet the peak load requirement. The capacity of a crusher used in central plant is high as 600 tons per hour. The sizers are used along with the crushers for the separation of a coal of required size. The crushed coal is passed over the sizers, removes unsized coal and feed back to the crusher. The sized coal is further passed to the dryer to remove the moisture from the coal. The coal dryers are used in order to remove the excess free moisture from the supplied coal or if it is wetted during transport. Hot flue gases are passed through the coal storage in closed space for removing the moisture from the coal. Before supplying the coal to the storage hopper, the iron scrap and particles are removed with the help of magnetic separators. Okay, so you can see the figure here. The removal of iron particles, it is necessary as they may choke the burners and may increase the wear of handling equipment. The separator is usually a magnetized pulley over which the loaded coal belt is run. The iron particles cling to the belt as it travels with the magnetic pulley, whereas the coal falls on the sooner. The iron particles drop off into the rejector chute as the belt leaves the pulley. Thus, the coal and iron quickly separated. The arrangement of a coal preparation plant is shown in this PowerPoint presentation. Okay. Next is ash handling system. Environmentalists throughout the world are seriously concerned about the deteriorating the air quality attributed to the emission of harmful gases on and from industries, powerhouses, factories, etc. While countries, particularly in the developing world, are making rapid strides towards industrialization, demand for energy increases with accelerated intensity. The fossil fuels are majorly sources of energy and its demand increases with accelerated development. Conventional fossil fuels are major of sources of energy required to meet such demand. The scenario is likely to continue in the foreseeable future. Coal has been major source of energy, meeting nearly 28% of the world's primary energy usage. Coal-fired power stations are about 55% of the coal produced in the world. Coal-fired powerhouse station houses are the main source of electric power in India, contributing nearly 75% of the total power resources today. Okay. The disposal of ashes from the large capacity power station is of some importance as it is 10 to 20% of the coal used. A 200 megawatt capacity power plant using Indian coals produces as large as 60,000 tons of ash per annum. You can just imagine the quantity of ash we are generating is around 60,000 tons per annum. The quantity of ash is equivalent to height of 1.5 meters covering 4 hectares area. Height is 1.5 meter which covers 4 hectares area. Can you imagine that? The tremendous amount of land we required for the storing of this ash. This shows that the power plant of 200 megawatt capacity requires 160 hectares area during its lifetime if ashes produced are dumped at the site of the plant. The ashes should be discharged and dumped at the sufficient distance from the power station because of these reasons. First is the ash is dusty, therefore irritating and annoying to handle. Second is it is sufficiently hot when it comes out of the boiler furnace. Third is it produces poisonous gases and corrosive acids when mixed up with the water. So these are the major reasons by means of which we need to handle the ash very carefully. Now next is general layout of ash handling power plant. The ever interesting capacities of boiler units together with their ability to use low grade high ash content coals have been responsible for the development of modern ash handling systems. The general layout of the components used in modern ash handling system and dust collection plant is shown in this PPT. It contains four mainly systems. Okay, first is the mechanical handling system, second is the hydraulic system, third is pneumatic system, and fourth is stream jet system. So here next point that to be discussed is electrostatic precipitator. It was developed by Dr. Cottle in 1906. It is the oldest and successful process which is developed by F.G. Cottrell and used in chemical plant at San Francisco. This was the real beginning of industrial application of electrostatic precipitator. In this system, the particles in the air stream are charged using corona discharge and then collect them on the grounded plate through the Coulombic attraction. Although it is simple in principle, it is very difficult to translate into the practice as an electrostatic precipitator involves in complex interaction of electrical, mechanical and chemical factors. As 100 years are already passed after its introduction in practice, it is very well developed and successfully used in removing the ash particles from the exhaust gases coming out from the boiler and combustion chamber. The electrostatic precipitator are extensively used in removal of fly ash from an electric utility boiler emissions. Use of this collector increased rapidly because of strict air quality codes given by Government of India. Around 30 to 60,000 volts current need to be applied between two conductors. Dust is passed through the high charged and highly charged electrodes. An electrostatic precipitator can be designed to operate at any desired efficiency for the use as a primary collector or as a supplementary unit to the cyclone collector. It is often considered worthwhile to retain an existence of cyclone as a periphery collector in cases where collection efficiencies must be upgraded, especially where there is large amount of unburnt carbon in fly ash, about 15%. Because of the presence of large quantities of carbon in the gas can adversely affect the collection efficiency of a precipitator. Now the working principle of electrostatic precipitator here illustrated. The dust laden gas is passed between oppositively charged conductors and it becomes ionized as the voltage applied between conductors is sufficiently large. About 30,000 to 60,000 volts need to be applied, as we have discussed earlier about it. As the dust-laden gas is passed through these highly charged electrodes, both negative and positive ions are formed, the latter being as high as 80%. The ionized gas is further passed through the collecting unit, which consists of set of vertical metal plates. Alternate plates are positively charged and earthen. As the alternate plates are grounded, high intensity electrostatic field exerts a force on positively charged dust particles and drives them towards the grounded plates. The deposit dust particles from the deposited dust particles are removed from the plates by giving shaking motion to the plates with help of cams driven by external means. The dust removed from the plates with help of shaking motion is collected in the dust hoopers. Care should be taken that dust collected in hooper should not be entered into the clean gas. So that is the working principle of electrostatic precipitator.